Hi guys, today we're going to discuss about thermodynamics of ideal gases. So this will be a summary, of all the equations that we will be using when you are working with ideal gases in thermodynamics. So as you can see, we have different processes here. We have the isochoric process, isobaric process, isothermal process, and the adiabatic process. So we have here the summary of the equations that will be useful to you in different processes. So we will be showing yung mga equations natin in ideal gas, our equations for work, heat, internal energy, and enthalpy. So of course, we will not be discussing a lot in details about each processes because these are just an overview or the summary ng mga equations natin, Of course, we will be explaining a bit about this, but if you want to learn more in details about these processes, then you will have to watch our separate videos about these processes. Each of these processes, we will be having a separate video which will be releasing anytime soon. On that video, hindi lang natin basta i-derive itong ating mga equations, but we will be also solving problems, related to each of these processes para makatulong sa inyong pagre-review in thermodynamics. And to understand further itong mga equations natin dito, we also advise to watch yung mga previous videos natin in thermodynamics to understand what is work, heat, enthalpy, internal energy, and ideal gases. Para itong mga discussion natin dito will make sense, sa mga pinag-aaralan natin. But of course, in our succeeding videos, we will be discussing each processes in detail with additional solved problems, So marami tayong kailangan pag-usapan sa topic na to. So let us not delay further and let us now jump to our discussion. But before we proceed in filling this table, let us first review yung natutunan natin in first law of thermodynamics. This is really important because in different references, you will find some differences on the formulas or equations that we will be presenting here. If you remember, in first law of thermodynamics, we have our delta U or the change in internal energy, which is equal to Q plus W. And the sign of our work W differs from one reference book to another. Sometimes you will find this as delta U is equal to Q minus W. And on some references, you will find this as delta U is equal to Q plus W. And to learn more about that, please watch our video about the first law of thermodynamics para you will know kung kailan nyo gagamitin yung plus W or minus W. But on this discussion, we are going to consider this equation. Delta U is equal to Q plus W. So let us start with isochoric process. So when we are working with isochoric process, this actually means that we are working in a constant volume process. So that means our change in volume is equal to 0. Because we are operating in constant volume process. So yun yung ibig sabihin ng isochoric process, constant volume process. And if you remember in our ideal gas law, ano yung ginagamit nating ideal gas law when we are operating at constant volume process? We are using the Gay-Lussac's law, which is P1 over T1 is equal to P2 over T2. So this is the Gay-Lussac's law, and we have a separate video about this as well. So this is the equation that we are using when we are working in ideal gases under constant volume process. So now if we are operating in constant volume process, that means our delta V is equal to 0. So if you remember in our video about work, we learned that work is equal to negative PdV. Or negative P delta V. But since our dV or our delta V is equal to 0, so that means when we are operating at constant volume process or isochoric process, that means our work is actually equal to 0. So madali siyang matandaan, because we have a formula W is equal to negative PdV. But since our dV is equal to 0, so that means our work is equal to 0. Now, we also understand or we learn from our video about heat and also our video about the specific heat capacity. We learned that at constant volume, our Q is equal to N CV delta T. Or this is also N CV T2 minus T1. Okay, so this is equal to Q, where N is the number of moles, CV is the specific heat measured at constant volume, and T2 minus T1 is in Kelvin or degrees Celsius. Okay, so we learned that in our chemical engineering calculations, right? That the change in temperature in Kelvin is just equal to the change in temperature in Celsius. Okay, now how about for our internal energy? So if you remember, we have this equation for first law of thermodynamics, right? So we have delta U is equal to Q plus W. Okay, but our W is equal to 0. Okay, so that means our internal energy is just equal to heat Q. Okay, so that also means that our delta U is equal to N CV delta T. Katulad lang nito. Okay, so it's easy to remember, right? Now, for enthalpy, as you know, we have a separate video about this one. We learned that enthalpy is equal to delta H, which is equal to N CP delta T, which is the CP is the specific heat capacity measured at constant pressure. Now, we learned in our lecture about specific heat that there is a relationship between CV and CP, right? And we could write that here. The relationship between CP and CB. We have our CP, okay, minus CV is equal to the universal gas constant R. Okay, so we have that relationship between CP and our CV. And we discussed this in our lecture video about specific heat, right? So if you want to understand more about this, so I am recommending to please watch our video about specific heat. Okay, so we already finished our raw for isochoric process. Okay, so now we are going to fill this space for the isobaric process. Now, what do we mean by isobaric process? So in isobaric process, that means we are operating in a process at constant pressure. So that means our delta P or the change in pressure is equal to 0. Okay, so ano yung ideal gas law na ginagamit natin when we are operating at constant pressure process? Okay, so we also have a separate video about this, and I'm talking about Charles' law. So in Charles' law, we learned that V1 over T1 is equal to V2 over T2. Okay, so we are using this when we are working in a process at constant pressure, no? So ito yung ginagamit nating ideal gas law to get the value of any variables here, no? Given the 3 variables, you can immediately take kung ano yung another variable natin using the Charles law. Okay, so in here at constant pressure, we will be using our formula for work, which is W is equal to negative P delta V. In which, since we are working with ideal gases, this can also be written as W is equal to negative NR delta T. Okay, so we will be working more about this, or we will be explaining more about this in our separate video about isobaric process in ideal gases. So for now, don't worry about the derivation, how we arrive on these equations, because we will be explaining that in detail in our separate video in isobaric process. The same in other cases in here. Now we will be discussing that in detail or in depth in our separate videos about these processes. So for now, we're just giving you an overview or a summary of these processes para magamit nyo siya when you are reviewing. Now, since we are working in constant pressure process, we also learned in our video about heat and specific heat that our heat, which is Q, is equal to N Cp delta T, where N is the number of moles, Cp is our specific heat capacity measured at constant pressure, right? So we will be using that because we are working in constant pressure in here. In the same way, we have our delta U, our internal energy, which is equal to N Cv delta T. Okay? And of course, we will still be applying yung ating first law of thermodynamics, which is Q plus W. Our delta U is equal to Q plus W. Okay? And in here, we will have a derivation, which we will be showing you in our video about isobaric process. And you can also get these derivations sa aming video about enthalpy. No? We learned in our lecture about enthalpy that delta H is equal to Q when we are operating in constant pressure. So that means our delta H is also equal to N Cp delta T. Okay? So again, don't worry kung paano natin to nakuha. No? Don't worry about the derivation because in our separate video about isobaric process, we will be discussing that a little bit more. No? Now, we have isothermal process. So what do we mean by isothermal process? In this process, we are operating in constant temperature. That means our delta T is equal to 0. Okay, since we are operating at constant temperature process. Okay, so if we are working in constant temperature process, anong ginagamit nating ideal gas law? Okay, so alam natin to in our general chemistry course, no? So we are using the Boyle's law when we are working at isothermal process, and according to Boyle's law, our P1V1 is equal to P2V2. Okay, so this is Boyle's law. Now, I'm going to skip work because it is easier to explain about the internal energy and enthalpy, no? Para ma-close kagad natin itong ating discussion. As you can see, our delta U is equal to NCV delta T. And our delta H is NCP delta T. No? Lagi tayong meron change in temperature. But since we are working at constant temperature, so there will be no change in temperature in here. So that means our delta U is equal to 0 and our delta H is equal to 0. So this is our case when we are working at isothermal process or constant temperature process. And for our heat, we have to take note again about our first law of thermodynamics, which is delta U is equal to Q plus W. Okay, but since our internal energy is equal to 0, because there is no significant changes in our internal energy, no? Kaya our delta U is equal to 0. So that means our Q is simply equal to negative W, right? So our Q is equal to negative W. Okay? Now, how about for work? We know our equation for work, which is equal to negative P delta V or PdV. So this still applies, no? But working on this equation, we will be able to derive this equation. W is equal to nRT and ln V1 over V2. Okay, similarly, we can also write this as W is equal to nRT ln P2 over P1. Okay, so we could use that for our work at constant temperature process or isothermal process. So again, don't worry too much about this equation. We will be explaining that in a separate video about isothermal process. And we will be solving problems as well para mas ma-explain natin siya ng mabuti, no? Mas maintindihan natin yung isothermal process. Now, how about adiabatic process? Okay? So, what do we mean by adiabatic process? So, in adiabatic process, there is no heat enters and leaves the system. Okay, so let me write that para mas magkaroon tayo ng magandang definition in adiabatic process. In here, no heat enters and leaves the system. So that means if there is no heat enters and leaves the system, so our heat in here, our Q is equal to 0 because there is no change in heat in our system, right? So in our first law of thermodynamics, we have our delta U, which is equal to Q plus W. So in here, our Q is equal to 0 in adiabatic process. So that means our delta U is equal to W. Okay, but don't also forget that our delta U is equal to N CV delta T, right? So now, as you can see, our delta U is equal to W. So that means at adiabatic process, any work done is at the expense of internal energy. Okay, because our Q is equal to 0. Okay, and in this case, our delta H will still be equal to N Cp delta T. Now, we have our adiabatic process in here. Sometimes you will encounter when you are working with adiabatic processes, no? Sometimes you will encounter a term which is isentropic process. Okay, this actually means that the process is operating at constant entropy. But this is actually also the same as saying that our process is operating at reversible adiabatic process. And if we are operating at reversible adiabatic process, our work can also be calculated as NR times T2 minus T1 over K minus 1. So this is applicable if we are working in non-isothermal condition, no? So that means our temperature is changing, because otherwise, if it is an isothermal condition, that means our delta T here will be 0. Now, ano tong tinatawag nating K dito? Because we know that N is the number of mole, R is the universal gas constant, and we have temperature 2 and temperature 1. So what do we mean by K in here? And we actually discussed this in our video about heat capacity, no, or specific heat. And we learned from that video that our K is actually the ratio of CB or CP over CV. Okay? And also CP and CB has this relationship. Now, CP minus CV is equal to R. And we also discussed this in our video about specific heat. Now, how about for this ideal gas law? So, if you remember in our general chemistry classes, we are not discussing this process, you know, the adiabatic process for ideal gases. Now, if you refer to thermodynamics or physical chemistry books, you will find a different way in expressing the relationship between pressure, volume, and temperature for ideal gases when we are operating in reversible adiabatic process. For example, we will have our P1 V1 raised to K is equal to P2 V2 raised to K. Okay, again, our K here is the ratio here, Cp over Cv. Then we have here our T2 over T1, which is equal to V1 over V2 raised to K minus 1, and we also have T2 over T1 is equal to P2 over P1 raised to K minus 1 over 1. Okay, so these are the same equations that you will find in Introduction to Chemical Engineering Thermodynamics by Smith and Van Ness. Okay, you will find this on that book. Okay, so don't be confused that these equations are replacing itong ideal gas laws natin dito. But this is actually a supplement. Okay? This is the term that was used by Maron and Lando in physical chemistry. This does not replace itong ating ideal gas laws, but rather is used as a supplement when we are operating in a adiabatic process. Now, we know that our K here is equal to CP over CV. Okay, so if we know the value of CP and CV, or our R and CV, then that means you can take the value of K in here. Now, we can use that in order to use these equations. Okay, but if you refer again to Smith and Van Ness, there are values there that you also need to take note. For example, according to that book, if we are working with monatomic gases, so let's say monatomic gases, our K is equal to 1.67. And if we are working with diatomic gases, our K is equal to 1.4. And finally, if we are working with polyatomic gases, our K is equal to 1.3. Okay, so examples of polyatomic gases are carbon dioxide, SO2, NH3, CH4, and so on, right? So these are examples of polyatomic gases. And by the way, I forgot to write here that we can also have our work here as P2 V2 minus P1 V1 over K minus 1. Okay, so we will be deriving that as well in our separate video about adiabatic process. But for the meantime, no, I think this will be useful, lalo na kung napanood na ninyo itong ating mga video, separate videos, I mean, about isochoric process, isobaric process, isothermal process, and adiabatic process. So, magiging madali ito as a reviewer, no? Dahil naka-table na rito yung mga equations na gagamitin natin at different conditions. Now, on separate video about these processes, no? Itong mga process natin dito, hindi lang natin yun basta kukunin itong derivations, but also we will be solving problems para makita natin how do we apply this process in our thermodynamics problems, no? Okay, so that's it for now, guys. So, I hope nakatulong sa inyo itong lecture video natin for today. I would suggest to wait sa ating lecture video about these processes, no? We will be preparing that on the coming days. So, that's all for now. Thank you very much and have a nice day. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.